So, chapter 3 is financial analysis and control. So, let's get started here. So, first, the definition. Financial control is the process of measuring and monitoring the business's performance over time in order to maintain desired standards of performance. Okay, so the word control, you really want to understand this just from like a human perspective. So think of, let's say, the human body, right? The human body needs to be at a certain temperature, it has to operate in a healthy way, and then that person or an individual is considered healthy. Okay, so if something happens, let's say you get sick, your body tells you that hey, you need to take corrective action so that we can return to said healthy state. So this is pretty much how you want to think about, finance as well. Financial control, you take certain steps where you maintain the standard of performance, and then if something happens, like, profitability drops or some exogenous shocks, like external shocks happen to your business, you try and take corrective measures. Okay? So we have a certain group of steps which we can sort of state. So identifying goals, that is, what is the standard you want to have? What is the profitability level? What size company or agribusiness you want to be? You develop measures for those goals. What actions you have to take? So again, the analogy with the human health. If you want to be healthy, of course, take lots of fluids, go exercise, etc., etc. You determine norms for the measures. You set tolerance levels. So again, anything cannot be a fixed target. It has to be a bit of a movement in the sense that if you're thinking of, let's say, healthy weight, you're thinking of, okay, I need to be between X amount and Y amount, and then those will be my tolerance levels. So you develop an information system, selecting and administrating the analytical and diagnostic tools, and then of course identifying and implementing corrective actions in case you feel something is happening which is not giving you the standard performance that you want. Okay. Uh, the characteristics, of course, of goal measures. The decision maker should choose measures that are both meaningful and manageable. Okay. So again, the definition, of course, is slightly different from the English meaning here. Meaningful and manageable. We're talking about meaningfulness refers to how well the measure actually reflects the stipulated goals. Okay, so what do we sort of mean by that? So for example, if profitability is the goal, then crop yields per acre or milk production per cow would not be a very meaningful since other factors also influence profitability. Okay, a dollar measure of profitability would be preferred. And then of course, they have to be manageable. That is, the ease of computation, and so they should be easy to compute and to comprehend. And then of course, the number of measures involved should be manageable. So we'll be looking at, four main tools of analysis. Okay, so we have the comparative financial statements, you have the index number trend series, and the common size financial statements, and of course the specific financial performance measures. The last one, the specific financial performance measure, is, I would say, the most important, I want to say, because it does involve a bit of calculation. And just if you look at broader finance, these are very, very useful. So we'll be going over them in a bit detail. Okay, so let's start with the first one. A comparative financial statement is nothing but doing a side by side comparison. It literally comes from the word comparative. So you have a balance sheet in year one, and then you have a balance sheet in year two. And all you do is you simply compare. You look at the columns on both sides, and then you see that, okay, how do they differ? So this is just not rocket science. This is just as straightforward as it's going to get. Okay. The index number trend series is something that's important. We'll get to in that just a second. And a common size financial statement simply represents each item on a financial statement relative to a total value for a category of similar items. So, what do I mean by that? So, basically, a common size financial statement utilizes this idea of an index number to do what's being done in point one. Okay, so what were we doing in a comparative financial statement? Suppose you had like two balance sheets and you're trying to sort of compare year to year. The problem though is in those two balance sheets you're simply looking at raw numbers. So what you're not doing is that you're not sort of seeing the growth or the decline in two numbers. You're just directly looking at the numbers. Now, of course, you can directly look at the numbers and make a conclusion based, conclusion that the company's doing did well or did bad. But what a common size financial statement does is that it sort of indexes and it structurally clarifies the differences between two separate years. And then, you don't just have to have 2 years, you could have multiple years. Okay. And to sort of understand that, let's sort of take a look at this idea of an index number. So, index number trend series is best for long-term trends, and then all you do is that an implementation requires a base year. So what do I mean by a base year? A base year is nothing but a base year is nothing but a year on which you make judgments about all other years. So let's say you select the base year, I don't know, 2010. So 2010 is the year through which you look at all other years. So you compare 2010 to 2018 to 2017, etc., etc. Or maybe, you can even go back further from 2010. So an index then is simply the value in a specific year over value in a base year times 100. So as an example, so value in a specific year could be, so you have an agribusiness and your current assets in 2018 are $5 million. And then your current assets in a base year were about $3 million. So 5 million over 3 million times 100 is your index. So the value indicates the percentage of the same amount in base year. Okay. And let's do a really quick example here. Suppose you have current assets in 2012, okay, at dollar 500,000, okay, and then suppose in 2010 the CA, or the current assets, was equal to 300,000, okay, and suppose that your base year, the year which you will use for all your comparisons, is 2010. Okay, so that's your base year. So how do we then find an index for, let's say, 2012? So index for 2012, and let me just go ahead and do Alt Q. Simply equals value in current year. So if we're doing for 2012, which we are, value in 2012 divided by, let's do a bracket here, divided by value in 2010, because 2010 is your base year. Okay, so again, value in current year over value in 2010, which is your base year, times 100. Okay, and then all you have to do is you simply do values 500,000 divided by 300,000, okay, which of course equals 166. Again, there's a times here, excuse me, times 100 equals 166.67. Okay, and what is the interpretation? The interpretation is that compared to 2010, okay, compared to 2010, the index in 2012 is 66% more. Notice how in 2012, 66%. So all you do is, you look at the two numbers after the one. It is 66% more. And suppose this number was less then all you do is you look at the difference between 100 and whatever that number is, and that is your decline. Okay? So then let's take a look at this table. And in this table, you can pretty much clearly see how if 2008 is considered your base year, okay, and here you have, let's say, two people, Joseph and Elise, but 2008 is considered the base year. Then you can see what happened in 2009, 2010, 2011, okay? Relative to 2008, your total assets grew by 4%. Relative to 2008, in 2010, your relative assets grew by 7%, and in 2011 by 13%. Notice how your liabilities declined from like 96 to 93. So here the decline by 4%, here the decline by 7%, and here the decline by 13%. So you can see how if 2008 is your base year, that is 100, then the comparison can be made. But again, we'll do a problem here just so that this idea is more clear in terms of just a longer series. Like here we just looked at 2 years. We can do like a longer series like in this question. Okay, the assets, liabilities, and net income for Duke Farms over the past 5 years is this. Okay, so here you have farm assets, you have farm liabilities, and of course you have net farm income and operations. Using 2006, so using 2006 as the base year, calculate an index number trend series for assets, liabilities, net worth, and net farm income from operations. Okay, now notice again, all I want, so you can pause the video, do it on your own, but remember what the question is asking you. Calculate an index number trend series 2006 as your base year. Okay, so think about what you're doing. All you're doing is you're using value in the current year divided by value in the base year times 100. Okay, so again, I hope you can do this on your own, but let's go ahead and complete this table. Okay, so value in the current year. In 2006, the current year value is 350, 105. Okay, divided by value in the base year. Notice 2006 is the base year as well. So it is going to be the same value. Okay, it is going to be 350, 105. Okay, and then of course times this thing is times 100. You will notice that this will cancel with this, and then you'll simply be just left with 100. Okay, and the same idea is true for the farm liabilities and net income. It is going to be value in the current year, so that's 104, divided by value in the base year, that's 104, okay, and then of course times 100. Okay, times 100. So this will cancel with this right here, and then again you will be left with 100. The reason you have 100 here is because 2006 is your base year. So when you're comparing the base year to itself, you're always going to get 100 because 100 is your starting point. That's where you make all of the comparisons from. Okay, and then the same thing is true for net farm income from operations. Okay, so now take your time and see what's going to happen in 2007. So in 2007, the value in the current year is 367,610. But what is the value in the base year? In the base year, the value is 350,105. So in the denominator here, you're going to get 350,105, and then you simply multiply it by 100. Okay, so it's 367,610 divided by 350, 105 times 100. Whatever this value is what your index says. Okay, so then this number is 104.9. Okay, let's go on to the next one, the farm liabilities. That is 124,601 divided by this number here, the base year. 124 is your current year, and then 125, 104 is your base year. Okay? Divided by that, 104, and then of course multiplied with 100. So then you get 99.5. Okay? And then you can do the same thing for all these years. Okay? I'm going to do the last one here, and then I'm going to leave the others for you to do. So equals, so in 2007, it is going, for net farm income, it is going to be 25,103, which is this right here, which is the value in the current year, divided by 38,008, which is the base year. This divided by this times 100 is your index, which of course is 66.04. So notice what the interpretation is. Your farm assets grew by 4.9% in 2007 when compared to 2006. Your farm liabilities declined by 0.5%, and then your net farm income from operations declined by 34, almost 34%. So that's the difference between 100 and 66.04. So then for 2008, this is the value in the current year divided by the value in the base year, and then of course times 100. Okay, so I'm going to go ahead and leave these for you to stop the video and finish up. Okay, and then let's move on to the next thing. So we just learned about common size financial statements, and again, each item on a financial statement relative to a total value for a category of similar items. Again, so the purpose is structural components can be more easily accessed, and then percentage changes, of course, are easier to observe. So, you can clearly see here, for instance, let me just zoom this a bit right here. Okay, so you can see that you have cash savings and marketable securities. So this, it's pretty much an index. So you have a total index, total current assets, and then total non-current assets. When you sum these up, 26, 74, they all sum up to 100. Okay, but you can notice how there are differences. Let's say in total current assets, you will see like from 2007, 2010, in 2009, for instance, was only 24, and then in 2011 was only 24, and then you see the differences reflected in non-current. And the way these numbers are calculated are literally the way I just showed you. Okay, so again, in the exam, I'd be more interested in doing something like this instead of completing the whole balance sheet. That's of course going to be super time consuming, so we're not going to do that. But something like this, where I'm asking you to calculate an index for, let's say, a group of small things, farm assets, liabilities, net farm income, etc., etc. Okay, and then of course, you have a more broken down version of the thing before. You can see again, you have a common size income statement where you have value from farm production, non-depreciation operating expenses, interest expense. Notice how this is everything has been clubbed together. If you recall from the previous chapter, in an income statement, you have the farm revenue, farm expenses, and then non-farm adjustments and income taxes. Everything here, instead of being separated by each category, all items are pretty much put together in like a single column, and then you can see that they have been converted to index numbers, and you can see the breakdown for each single category. Okay folks, so then let's move on to Okay, so then let's just move on to specific financial performance measures. These are the profitability measures, the liquidity measures, the balance sheet measures, the cash flow liquidity measures, and of course, solvency and financial risk measures. In this particular chapter, we really do want to focus on some of these profitability measures, and why do we have these categories? Okay, so let's just talk about profitability for instance. Profitability can be measured basically in several ways. the level of net farm income, and that's obviously something that's in the income statement. We just worked on that in the previous chapter. But the point is, if you are somebody like Tyson, and you could be somebody like an agribusiness A, which is not as big as Tyson Foods. So if it doesn't make sense to compare the net farm income of the two. Okay, so the problem is that if you're trying to see that on a relative level, which agribusiness between, let's say, Tyson Foods and some small agribusiness, which of them is doing a better job in terms of, their finances, then net farm income cannot be, or your net income cannot be your defining profitability measure. Okay, you need something better in that case. Okay, so um, which is why we have to look at some of these measures. Now, under profitability, of course, net farm income is a solid measure. You definitely want to start with that. Yet not useful for comparing one firm to another, or if there's some established standard which typically you want to adhere to. So net farm income has its drawbacks. This other thing is known as EBI DTA. Okay, so basically, again, that's just an acronym for a collection of words. So those are earnings before interest. So of course, earnings before interest, taxes, depreciation, and amortization. Okay, so earnings before interest, taxes, depreciation, and amortization. So again, I have the D in front of the T, so maybe like you can do TD. Okay, so EBI TDA. And the word amortization, what does that mean? So amortization is nothing just but you paying off your debt. Okay, so for example, let's say you have a car, and you're making fixed payments, most likely monthly installments, and you're paying the loan back. Okay, so what basically what that is, the terminology that we use for that is amortization, because if you're an agribusiness, paying back the loan is a cost to you. Okay, so then you have to sort of account for that in your final profitability measure, because if you're paying off a loan, it's going to be a cost to you because of the interest involved. So hence that word amortization. Okay, so how do we then calculate this EBI DTA? So it's simply the net farm income from operations, something that we sort of worked on in the previous chapter, plus the interest expense, plus depreciation, and then of course the amortization expense that I just mentioned. Okay, so the interest expense is nothing but if you have loans and then eventually you have to pay those back, uh, they're all part of the EBITTA. So again, you could have any number of examples, but as you can see, the calculation is fairly straightforward. Now, let's get to the main ones. The three profitability ratios. The rate of return on farm assets, perhaps the most important term in terms of when you think not just of agribusinesses but big companies. If you are somebody who's looking to buy stock in a company, you really want to look at the rate of return on assets. Of course, here we're going to use farm assets because in ag finance we're typically dealing with agribusinesses. Rate of return on equity and rate of return on assets are two very, very important concepts. And then, of course, you have the operating profit margin ratio. Okay, so intuitively, what exactly is rate of return on farm assets? So it is the ratio of the return that you get by using your farm assets over an accounting period. And when I say the word an accounting period, I mean over a season, most likely. Okay, so just think about it intuitively. You bought all this stuff, you bought all this equipment, you have all these assets. All the rate of return on farm assets is pretty much telling you is that the assets that you have, how much return are they actually bringing you back in? Okay, so if your rate of return, for instance, is a negative, or it's very, very small, if this ratio is very, very small, then you can sort of get a sense of the fact that, hey, I am probably not making the best use of my assets. Okay, so the return, is simply calculated by NFIO, which is the net farm income from operations, something that we just looked at in EBIDTA, plus the farm interest expense minus the value of operator and unpaid labor. So again, many times, obviously there's labor charges that you may have. It's entirely possible that LC is sometimes zero, especially if you don't have any, unpaid labor. And then, of course, you have other net income, which is added on. Notice that uh, there's a negative here because the LC is pretty much a cost to you. So the NFIO plus ID minus LC plus OT is your return. And then, of course, return over the average farm assets over the accounting period gives you the rate of return on farm assets. Okay. Also, a quick point to note here is that, again, when we're trying to figure out the return on farm assets, what do we mean by the average farm asset? So the thing that we'll be using here, and what is also common practice in the real world, is that you look at, 2 seasons. So let's say you have farm assets in 2009 and then you have farm assets in 2010. It is the average of the two that is used here. Now it's possible, you can have more than one two periods. You can look over a number of periods, but typically, we're looking at an accounting period. So let's say you have values for 2009 and then values for 2010. You take the average of the two, and then of course you get, you know, this number which you can plug in here. Okay, so then the next thing is the return on farm equity. Okay, now remember, when we're talking about equity, again, don't forget the main idea: assets equals liability plus owner's equity, net worth or total equity, whichever terminology you want to use, they are all the same. Okay, so over here, return on farm equity equals IE over E. Now, again, IE is simply equal to net farm income from operations minus LC plus OT. And the definition of each of these three is the same as before. So, what's the difference between R and then IE? The difference simply is that we do not have this farm interest expense in this right over here in the IE. Okay, so and capital E is, of course, average farm equity over the period. Okay, so remember, we have average farm assets and then average farm equity. They're different things, and everything is again coming from that equation where we have assets equals liabilities plus net worth or owner's equity. They can be interchangeably used. It's the same thing. And the intuition behind this ratio, again, the need for this ratio is that this represents the return to farm equity employed in the farm business. Okay, so basically, the cost of debt financing has been accounted for in calculating this measure. Okay, the calculation of the rate of return on farm equity, it's basically, and then the last measure in this profitability section is the cost of farm debt. That is simply ID over D, where, ID is the dollar amount that's interest paid and accrued on debt capital. Okay? And then, of course, you have capital D. D is the firm's average indebtedness during the accounting period. Okay? So remember, when I say indebtedness, start immediately thinking of liabilities. Okay, so let me just go ahead and write this down here. D is simply the firm's average indebtedness over an accounting period. Okay, so there we have it. Okay, and remember, the ID is the same as before. The farm interest expense. Okay, the interest paid and, accrued, that is how you find the cost of farm debt. So remember, just from the name itself, so COFD stands for cost of farm debt. So it's the cost of farm debt. If you took a loan to buy equipment, you have to not only return the loan, you also have to return the interest with it. So that's what that ratio is capturing, the cost of farm debt. Okay? The three measures that we looked at. R equals ID plus IE. A equals D plus E, that means it must be the case that ROFA equals ROFE times E over A plus COFD times D over A. Okay, now this is a very important slide. Okay, I'm saying that R, which can be seen over here, R equals ID plus IE. Okay, why is that? How are we going from this to this right here? Okay, notice that ROFE, this IE, equals NFIO minus LC plus OT. If I add ID, this ID over here, in this equation, I can then say call this whole thing R. Okay, so all I'm doing is I'm plugging this IE right over here to get this R. Okay, and if you don't believe me, let's just go ahead and quickly just show it to you. Okay, so all I'm simply saying is that if you have R equals NFIO plus ID minus LC plus OT. Okay, and then we also know that IE equals NFIO minus, excuse me, LC plus OT. Okay, so if you just look at combine the first three terms, okay, so you can rewrite, think of just, okay, think of the first three. Instead of using these, you simply replace them with this right here. Okay, so then that's how you get this term, R equals ID plus IE. And then of course, A, or average farm assets, equals average farm liabilities plus, average equity. And where is this coming from? This is coming from your good old fashioned assets equals liabilities plus total equity. Okay, so that is where this A plus DE is coming from. And again, you can simply see that using this. We know that A, or assets, equals liabilities, beg your pardon, assets equals liabilities. So these are total assets over total liabilities plus net worth, okay, which is also total equity. Okay, it's the same terminology. Okay, and all we're saying is that on average, so if you're going to average the two, this right here, the average assets equals the average liability plus the average equity capital. So here we're just simply incorporating 2 years, 2009, 2010, 2009, 2010, 2009, 2010. This relationship will hold. So the sum of the average liabilities plus average equity equals average farm assets. Okay, so that's the message here. And then if you manipulate this uh, ratio and this ratio and this ratio, you can have a joint relationship where the return on farm assets equals return on farm equity times E over A plus COFD times D over A. So if you want to have a joint relationship, if you know what this value is and if you know what this value is, you can calculate the return on farm assets. Okay, I do want to quickly point out that there's a lot more given in the book in like much more explicit detail, so please make sure you're reading the book as well. Okay? And what you definitely want to do is you want to plug in the ratios of ROFE and COFD and see that this actually holds. And if you want, we can go ahead and sort of like quickly do this. So here you can see that I actually went ahead and plugged in the formulas for ROFE and COFD in this formula. So what is ROFE? ROFE is nothing but this right here. What is COFD? It's nothing but this right here. And I went ahead and plugged it into this equation, and you can see how when you do it, this E and this E, which is the average equity, it goes ahead and gets canceled. This D and D goes ahead and gets canceled, and then of course uh, you will see that what is left is that it is IE over A, which is average farm assets, plus ID over A. You can combine the denominator because it's the same, and you're left with R over A, which is again nothing but the original formula for ROFA. So what I'm trying to show you is again that this thing over here holds. Now this is not only important for this from this exam perspective, but if you end up working for, as an accountant or in a place which does these kind of things, this is one of the most these three or four concepts are one of the most crucial things that you can actually learn. So this not only has just theoretical concept, this not only has some theoretical value, but you are really looking at some real world concepts here. Okay, so finally, you have what is known as the operating profit margin ratio. Okay, now remember, over here we're simply talking about the operating profit. Remember, when we were looking at the return earlier, the return also had the small thing called OT, which of course is other net income. So something you're supplementing your return not only from your operating profit perspective, but you're supplementing it from other sources. Operating profit margin simply focuses on your operating returns. So this OT is not there. This is R except without the OT there. And then this is the numerator, and on the denominator you have the value of farm production. If you recall from the previous lecture, the value of farm production is basically the sum of the farm revenue section of your income statement. I'm going to go ahead and ask you to pause the video, go verify that in the book or in the slides or in the video of the previous lecture that that is in fact the case, and you actually remember that. The NFIO minus ID plus LC over the value of farm production is the operating profit margin ratio. Okay? So let's go ahead and calculate the ROFA and ROFE and COFD. And of course, you can do this from this balance sheet data that's been given to you. Again, the font's a bit small, but I'm guessing in your slides you can actually read it. And also, this is table A3 in the books, so it should not be a problem. If you have the book, you can just simply go ahead and directly use the book to calculate this. Okay? So remember, first of all, we're trying to calculate what ROFA is. Okay? So ROFA. You need two things. You need R, okay, so you need what R is, and then you need what A is. Remember, A is the average farm assets. Okay, so let's just first worry about the denominator. So again, just to put it out there, ROFA equals R over A. This is what you're trying to find. Okay, so let's worry about the denominator first. A is your average farm assets. Now, when we talk about average farm assets, remember we talked about this idea of comparing two periods. Okay, so if I'm looking to find the average farm assets, the average farm assets for ending the accounting period of 2010, I'm going to look at 2009 and then 2010, take the sum and divide it by 2, and that is what the average is going to be. Okay, so this here is the balance sheet. So if you come down here in the balance sheet, you can clearly see, okay, so excuse me, you can clearly see right here in 2009 you have farm assets which are million dollars 18,342, and then in 2010 you have 1,070,098. So you need to take the average of these two to get your A. Okay, so your A is nothing but 1018, and I want to say that's 342, 342 plus 1070985, 1070985. and then you divide these by 2 and you get a particular number. 342 plus 107. And this equals 1044663.5. So this is your A. Okay, now we need to find what R is. Recall, R is simply NFIO, which is net farm income from operations, plus your interest expense, okay, ID, minus LC plus OT. Okay, so you have to then look at your balance sheets or your income statement to figure what this is. Okay, now if I take you to your income statement, okay, you can clearly see income statement summary for Joseph and Elise. Now remember, this ROFA that we're calculating is for 2010. Okay, and if you recall, we took the average of 2009 and 2010. So for if you're finding it for 2009, you take that year and the year previously because it's that accounting period. Okay, the accounting period began in 2009 and it ended in 2010. So the rate of return on farm assets for 2010 is going to be '09 and then '10. Okay, so you're still pretty much dealing in these 2 years. Please, and I see people make this mistake all the time. If I ask you 2010, people unfortunately sometimes do 2010 and then 2011, and that's not accurate. Okay, you always want to do the preceding year, not the succeeding one. Okay, and in the income statement, you can find that net income from farm operations in 2008 was 108,181. Okay, so I'm going to go ahead and write this down here. It was 108,181. Okay, plus the interest expense, which is also right over here, right below depreciation, and you can clearly see in 2010 was 29,280. Okay, it was 29,280 minus LC. So remember, this is the amount that you're paying. So again, charges for your labor, and you can find that right here in 58, cash withdrawals for family living. Notice this is sort of an income that you're going. So again, these are operator charges. This is the sort of income that you're giving yourself. So it'll have to come out of your own revenue. It'll have to come out from your own operations. So cash withdrawals for family living is in fact LC in this case. Now this is again slightly confusing because the terminology is different, but from here on out, if I have cash withdrawals for family living in the statement of cash flow, then I am referring, of course, to LC. Okay, so let's just go ahead and subtract 57. I want to say 70. Okay, and then of course you add other income, and you will notice that other income is interest and dividend income received on farm assets. Now, again, what I'm trying to say is that you have to be careful about how you interpret these things. Other income, the moment you see that there's income apart from your operations, which are listed here in the income statement, look at income statement notes. Okay, so you see here it's dividend income, but it could be income of any kind. But technically, it all comes under the umbrella of other income. So you simply go ahead and add this 900 over here, and then you can see that this, when you sum 900, leads to your R. So this value is that is equal to 8591. Okay, so now how do we then find ROFA? ROFA is then simply going to be equal to this value over this value. So it is 8591 over 1044663.5. Okay, which of course equals 0.0.071. Okay, or you can write that as 7.71%. Okay, whichever is comfortable to you. Okay, so this here is your rate of return on farm assets. Now I hope you have got some picture here. So again, I would strongly urge you to pause the video and try and work these other things, that is ROFE and COFD. I'm going to go ahead and do it anyway. Okay, let's look at ROFE. Okay, ROFE is rate of return on farm equity. Okay, so remember, all you need are two things. So you need, of course, IE, IE equal NFIO minus LC plus OT. And then, of course, you need E. So E is nothing but your average farm equity. Okay, so once you get those two things, then you simply have ROFE, ROFE equal to IE over E. Okay, if I were to then take you back right here, let's first find out what E is, that is capital E. So take a look at this balance sheet again. Notice how you have farm equity right over here. 2009, 2010, and then 505,968, 589,968. So again, please remember, don't just sum these up and leave it there. That is not your average farm equity. That's just going to be the total sum. You have to find the average farm equity. That's E. So what you need to do is you need to go ahead and sum and divide by 2. So divide by 2, and then of course we're going to go ahead and put a plus in between. So it is 505,968, 505,968, and then it is 589,986, 589,986. Okay, the sum of these two divided by 2 equals 547,977. Okay, and then we simply have to figure out what this IE is over here. Okay, so this NFIO we already know. Okay, it's this over here. So let's bring this back here. We already know what LC is. It is right from before. We just again, you can always go back to the income statement to look at it. And we put this over here. And then of course the other income is 900. Okay, this then equals 51,311. This is 51,311. Okay, so then you have IE, you have E, you simply plug in the values. 51311 divided by 54. Okay, and then this simply equals 0.93637, 0.09, I beg your pardon, which is of course 9.36%. And that's all there's to it. Okay, now let's go ahead and move on to COFD. COFD. Okay, so this then is simply going to be Um, Three things again. All you need is ID, you need average liabilities, okay? Farm liabilities. Don't do average liabilities, do average farm liabilities, okay? And then of course the formula is simply COFD equal to ID over D, okay? ID is farm interest expense, taking you back to the income statement. Interest expense in 2010, 29,280. You can also see this in ROFA when we used it ID right here, 29,280. We used it as part of R. Now you only need it. So I'm just going to go ahead and put that here. And then D is average farm liabilities. Let's go back to the balance sheet real quick. Farm liabilities right over here, 512,374 and then 480,999. The sum of these two numbers divided by 2. Okay, so the sum of those two and then divided by 2. So let's just go ahead and plug the numbers. So that was 512,374, 512,374 plus 480,999. 480,999. Okay, and then this simply equals 496,686.5. Okay, you have this value, you have this value. Simply go ahead and plug it into the formula. 496,686.5, and then this simply just equals 0.059 or 5.89%. Okay, so now we have ROFA, ROFE, COFD. What I would also encourage you to do based on all these values that we just found, try and verify this equation. Try and verify this equation right over here. Because again, good opportunity for an exam question and you should just know this to begin with. Finally, let's move on to the operating profit margin ratio. Remember, in the operating profit margin ratio, you do not need other income. Okay, so it's everything is just R except the other income term. So if I were to go back to this slide, beg your pardon, this slide, it's everything, it's just these three things except the other income. So I'm going to go ahead and take this and then the ratio, the OPMR ratio. So let me just, OPMR ratio is this, okay, this term, and then divided by value of farm production. Okay, where do we find that? Let's go back to this income statement right over here. Do you see the top point, line 37, value of farm production? Okay, in 2010 is 511,535. Again, a quick reminder, all the values that we're calculating, ROFA, ROFE, COFD, we're doing it for 2010. Okay, so you only use those values. If we do it for 2009, then for finding those averages, the average farm income, the average farm assets and farm liabilities and farm equity, you use 2008. So if we were looking at values for 2009, you would do 2008, 2009, take the average and then divide by 2. Okay, so value farm production, simply go ahead and then you divide by 511, 535, the top line, 511, 535. Okay, okay, and this is pretty much all there's to it. So let's just go ahead, and this is 0.155, and that is your operating profit margin ratio. Okay, so that concludes this example. Again, there's going to be homework problems and other problems for more practice. But let's move on to what is known as liquidity ratio. Liquidity ratio is nothing but current farm assets to current farm liabilities, taking you back to the balance sheet. You have, let's say, 2010, and then of course you have 2009. Remember, we're talking about current farm assets and current farm liabilities. It would be a mistake, I repeat, a mistake, if you directly use these values, 107 something. Remember, these are farm assets, including, that means, current and non-current. So we do not want to do that. Okay, we only want to do, for liquidity ratios, that is, we only want current farm assets to current farm liabilities. Okay, so how do we find that? What are current farm assets? So going back to the balance sheet, let's take a look at these first few lines in current assets. Remember, we're talking about current farm assets. So if you're trying to figure out, to look at the liquidity ratio, if you're trying to figure out what current farm assets is, simply sum all these values except all personal assets. Okay, personal assets, whether current or non-current, are not going to be part of your farm assets. Obviously here we don't have any personal assets, so basically current farm assets are the same as current assets, but you do not include personal assets. So here the total 291,775 is what you will be using to figure out what the current ratio is. And then the same idea for current liabilities. You do not include personal liabilities in it. Okay? To find the working capital, it is simply the current farm assets minus current farm liabilities. And then you have, once you have this, you can take the ratio between working capital to value of farm production, which of course we just saw right over here. Okay, so this is known as, collectively, these are, the liquidity ratios. Again, what's the significance? Why are we so worried about liquidity ratios? Suppose you get like current ratio where the current ratio is below 1. So then you are what is sort of known as being illiquid. Okay, so that the liquidity ratio is capturing the firm's capacity to generate sufficient cash to meet its financial commitments as they become due. So again, you may have bills coming up, and if the current ratio is below 1, that means you may be in a scenario where you don't have enough money to cover the bills that are coming to you. Okay, so you may be what is known as illiquid. Okay, so we don't, obviously, if you're a business owner or an agribusiness owner, you do not want to be in that scenario. Okay, now solvency is also equally important. That is farm debt to farm equity ratio. I beg your pardon, this should be farm debt to farm asset ratio, and then farm equity to farm asset ratio. Calculate the first one from the balance sheet. So I'm going to go ahead and leave that to you. Remember, we already know what farm debt is. We already know what farm equity is. Now remember, let's say I ask you to calculate the farm debt to farm equity ratio. Please do not take the average this time. Okay, now this time I'm simply asking for 2010, so you will directly use these values as is. Farm assets, farm liabilities. Okay, and then let's move on to the final topic, that is coverage and repayment capacity measures. So again, coverage ratios taken from income statement account for the relative claims of debt and equity holders on the returns to farm asset during a period. So basically, coverage ratios essentially relate a firm's financial charges to its ability to serve them. So again, you can sort of draw a parallel between what we were talking about with current ratios. Okay, so how do we find the interest coverage ratio? It is simply R over ID. Remember, we already know what R is, we already know what ID is, especially for 2010, the question that we were doing. I would strongly encourage you to plug in the values and calculate what ICR is. Okay? And then, of course, finally, you have efficiency, that is the asset turnover ratio. The higher the ratio, the more rapid the turnover of assets are into income. So, again, you always want to be as efficient as possible. Okay, so the implication being that if you're spending money, if you're buying assets, you rented land, you bought equipment, you want the money to come to you as fast as possible. Okay, so if this ratio, that means, let's say your value of farm production, remember, value of farm production is the sum of the farm revenue section. If this value for farm production is not as high as you'd like to be compared to your average total farm assets, we have a problem. Okay, that shows that you're not as efficient. You bought the land, or that you rented the land, you bought the equipment, but you're not being as efficient as possible. So the asset turnover ratio is very important because it is indicative of your ability to be a farmer. It is indicative of your management ability of your agribusiness. Okay, so that pretty much concludes this chapter. I would strongly encourage you to review everything again. Again, you have the video, there'll be homework, and then, of course, we'll be meeting in class to go over some of these problems as well. Okay.